In this video, we're going to be talking about families and their functions, and we're going to be translating and moving some graphs around on a coordinate plane. Okay, so a parent function is the simplest form of a function, and then it will form a family. So the family is going to be when we translate it up and down on a graph. So a parent function could look like this. In its translation, or its family, we could shift it up, we could shift it over, okay? But the parent function is the original function. Translation, okay? So if it sits on the outside of our equation and is a plus or minus, it's going to translate vertically or up or down. If it sits on the inside of my parentheses, it's going to translate horizontally or left or right. Okay, so I got y equals x, so this is going to be my parent function right here. And this is going to be the family that it's going to create. Okay, so I'm going to do the parent function in this color first. I'm going to zoom in. Okay, so it was y equals x, so my y-intercept is at 0. I'm going to go up 1 to the right 1, up 1 to the right 1, or down 1 to the left 1. Okay, so that is my parent function. Okay, now we're going to do this other one, so I'm going to pick pink here. So I'm going to do its family. So we start at -2 and we go up 1 over 1 again. So start at -2, we go up 1 to the right 1, 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 or down 1 and to the left 1. Okay, so this, you could see that the family, it got shifted a little bit. So this x -2, the -2 sits on the outside here. So the -2, the one that sits on the outside, it's translating vertically. Okay, so if it's -2, it's going to be translating vertically or up or down, and you can see that it is going down 2. It's going down from my peach graph to my pink graph. So that -2 is telling me that it's translating vertically down 2. Okay, this one we got our parabola. Okay, so let's go ahead and start this t chart here. So we're going to do -2, -1, 0, 1, and 2. And our original is y equals x squared minus 1. Okay, so I'm going to, when I take my letter out and put a number in its place, I make sure I have parentheses. So I got y equals -2 squared minus 1. -2 squared is 4. 4 minus 1, so this is 3. Y equals -1 squared minus 1. -1 squared is 1. 1 minus 1 is 0. When I plug in 0, I got y equals 0 squared minus 1. 0 squared is 0. 0 minus 1. We got -1. I'm going to erase this so I can do the next set. So y equals 1 squared minus 1. 1 squared is 1. 1 minus 1 is 0. And my last one, I got 2 squared, which is 4. 4 minus 1, which is 3. So let's go ahead and graph those points. So I go left or right and then up or down. So I go left 2, up 3. I go left 1, stay there. I go 0 and then I go down 1. I go right 1, stay at 0. I go right 2 and up 3. So there is my generic parabola that I got. Okay, it's a normal parabola. It's just shifted down 1 because that x squared minus 1. Okay, now let's go ahead and do my next one. So let's change colors here. So now I'm going to do -2, -1, 0, 1, 2 for my y equals x squared plus 4. So again, when I take it out, put it in parentheses. So y equals -2 squared plus 4. -2 squared is 4. 4 plus 4, so I got 8. Y equals -1 squared plus 4. -1 squared is 1. 1 plus 4, we got 5. So now we do 0. So 0 squared plus 4. 0 squared is 0. 0 plus 4 is 4. Y equals 1 squared plus 4. 1 squared is 1. 1 plus 4, we get 5. 2 squared. 2 squared is 4. 4 plus 4, we get 8. So I'm going to go left 2, up 8. All right. Let me zoom in here. Left 2, up 8. 1, 2, 3, 4, 5, 6, 7. There's that first one. Left 1, up 5. I stay at 0 and go up 4. 1, 5. Oops, this -2 one was supposed to be moved over to here. There we go. All right, so you can see that this, from pink to blue, it is moving up. How many is it moving up though? We got 1, 2, 3, 4, 5. So this one shifts up 5. Okay, a reflection flips the graph of a function across a line such as the x-axis or y-axis. Each point on the graph of the reflected function is the same distance from the line of the reflection, so you're going to be mirroring it to the corresponding original function. Okay, so let's put an original function on here. So let's do something like this. So if I'm reflecting over the x, it should mirror it. Let's change colors here. So here's my reflection over the x. It should mirror it across that x-axis. So it should look the same, just across the x-axis. If we're mirroring over the y, it should reflect the exact same over the y-axis. So it should mirror over the y. Okay, so here was my y pink, and my green was over my x. Okay, reflecting a function. So my original, or my parent function, is this 3x plus 3, so let's go ahead and graph that. So we start at 3. We go up 3, 1, 2, 3 to the right 1, or down 3, 1, 2, 3 to the left 1. Okay, and then we need to flip it over the y-axis. So my original function is this 3x plus 3. Well, flipping over the y, if we look, it is a negative x. So we need to make, my new function should be g of x, because it says what is the graph of g of x. So g of x, we need to make this a negative x, because that is what my rule said. Well, 3 times negative x gets me negative 3x. So now this is the new one I'm going to graph. So I'm going to start at 3, and I'm going to go down 3 to the right 1, or up 3 to the left 1, and you can see that it should mirror it over my y. So point for point, it should be mirroring over my y. You can see how those match up over the y, and those match up over the y. Okay? So they should mirror over that y-axis here. So we're going to graph the original. This time it's going to mirror over my x-axis. So we start with, starts at 3, it goes up 3 to the right 1, or down 3 to the left 1. So let's go ahead and continue it. Okay, so this time we're mirroring over the x-axis. Okay, so I'm going to graph this h of x. Let's see what my rule says about mirroring over the x. This time, the negative sits on the outside of my problem. Okay, so it sits on the outside of my problem, so we're just going to stick it out there to make it easy. But I need to get rid of it, so we're going to divide everything by -1. So basically, if you're going over the x-axis, it flips all the signs of your problem. It becomes a -3x and a -3. So when I'm graphing it, I start at -3, I go down 3 to the right 1, or up 3 to the left 1. And you can see that it mirrors point for point over your x-axis this time. So these mirror, okay? They mirror over your x-axis. Okay, vertical stretch. Vertical stretch multiplies all y values of a function by the same factor greater than 1. So vertical stretch, if it's getting fatter, it has to be bigger than 1, and it's always going to be multiplying your functions. Compression, it's going to be smaller than 1, so it's going to be more like a decimal this time, like 1/2. Okay, and it's also going to be multiplied by your function. Okay, so here's all of our shortcuts that we learned. We got horizontal translation right and left, reflection over x and y, vertical stretch and compression, so fatter and skinnier, and then vertical up and down. The graph of g of x is the graph of f of x equals 4x, compressed vertically by the factor of 1/2, and then reflected in the y-axis. What is the function rule for g of x? Okay, so my first step here is vertically by the factor of 1/2, so it's going to be compressed. So I need to multiply times that 1/2, because vertically compressing, you're multiplying that half in there. So 1/2 times 4, we now have 2x. okay? But then we need to reflect it in the y-axis. Reflecting in the y, we need to make our x negative. So 2 times negative x, which results in negative 2x, and I need my function rule for g of x, so we're going to change this to a g of x, because that is my family that I would then graph. What is a transformation changed? This graph f of x to the graph g of x. So how do I get from this to this? So how do I get from a 2 to a 6? Well, 2 times 3 gets me 6. So if I'm multiplying by a 3, if we're looking at our different things that we can do here, right here, the one that has something in front of it are these two. Okay, but it has to be bigger than 1 because it's 3. So we're vertically stretching or making it fatter. So vertical stretch by 3. And then we also have this minus 1. It's sitting on the outside, so if we go back, which one of these has it sitting on the outside? Well, our k's are on the outside of this one, and we're subtracting 1. So we're going down 1 unit. Describe the transformations. So this is sitting on the outside again. So if we go back to our things over here, it's sitting on the outside, except for this time it is a plus sign. So our plus sign here, we're going to be going up that many units. So we would be going up 6 units. This one, it's sitting on the outside and it is bigger than 1, so we are vertically stretching. Vertical. Ooh, Lord. Vertical stretch by 2.5. Okay, this one, the minus 4 sits on the inside. We haven't dealt with inside yet. So here's my inside ones, and it's a minus. So we're going right however many units. So this is right 4 units. This, my x is negative, and it's sitting on the inside. So if we look, then negative x sitting on the inside, it's going to flip over your y-axis. So reflect over your y-axis. Okay, we got f of x equals negative 2x, and we're going to translate it this amount. So let's go ahead and graph this parent function first. So we start at 0. We go down 2 to the right one, or up 2 to the left one. Go ahead and connect these. Okay, and now what we can do is look. So if I have plus 1 on the inside here, that's going to move it. If we're looking at inside of the parentheses, and it's a plus sign, we're moving it left that many units. So we're moving it left 1. So I'm going to look at all of my points. I'm going to use yellow for this, and I'm going to move all my points left 1. So that went left, 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 left 1, left 1, left 1, left 1, left 1. Draw my line. Okay, my next one is this minus 2 on the outside. So if I go back to my rules, minus 2 on the outside, so minus outside with the k here, we're going down that many units. So we are going down 2. So I'm going to move that point down 2 units for all of my points. So down 2, you pick that point. Remember, you're going off of your newly created one, and you're moving all those points down 2 units. And then connecting them. So that is your newly translated graph. Okay, this one, graph in the original, so we start at 0, 0, we go down 2 to the right one, down 2 to the right one, down 2 to the right one, up 2 to the left one, up 2 to the left one, up 2 to the left one. Okay, this one's a little bit trickier because we need to vertically stretch it. So my original right now is this f of x is equal to negative 2x. So we need to vertically stretch it by 2. So we need to make it fatter. So we're going to multiply this 2 in here times my original to make it fatter. Okay, this plus 1 we're also going to add into it. Okay, so we're going to multiply it so to get our negative 4x. And then we're going to shift it that 1 after we multiplied it. So we're going to add that plus 1 in here. So this is my new graph that we're going to be doing here. Okay? So let's go ahead and do our y equals to make it easier. Okay, so it's going to start, let's change colors here, at positive 1. And it's going to go down 4. 1, 2, 3, 4 to the right 1. Oops, to the left. Nope, to the right 1. Or up 4, 1, 2, 3, 4 to the left 1, up 4 to the left 1. And then we're going to connect those points. Okay, for this one you need to make sure you multiply it times the 2 first and then add 1 because you don't want to be distributing this 2 to both things. So your first step is to multiply your original function by 2 and then add 1 on top of it and graph it. Okay, we got our original x squared graph. So if I'm doing my x squared graph, I could make my t-chart. And it should look something like this. That was really bad. There we go. And then if it's sitting on the inside, if we go back to all of our things here, it's sitting on the inside. And it is a minus sign, so we're going right however many units that is. So we are going right four units. So each of my points, I'm then going to shift right 4 units. Okay, so I'm going to move all of my dots over 4 units. So 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Okay, so you can see how it is shifted over 4 units from our original pink graph or our parent function. Okay, write the function rule. So I got y equals x plus 1, or f of x equals x plus 1, and I need it reflected over the x-axis. So when we reflect over the x-axis, remember it is when we do the negative on the outside. So if I divide all these by negative 1, remember x-axis, we flip all the signs, so this becomes a negative x and a minus 1. When we reflect over the y-axis, it is a negative x. So 3 times negative x, which gets me negative 3x. Okay, write an equation for each transformation of y equals 4x. So vertical stretch, remember we're always multiplying that in. So we always do it times the number that's in front of x, and that's 1 right now, so we got 4x. Vertical compression, so we're making it skinnier. We do the same thing, except for this time it should be less than 1. So we multiply it times that x, so we got y equals 1/2 x. Okay, write the function rule of g of x. If f of x, so here is my parent function, is 4x. So we translate up 5 units and reflect over x-axis. So if we're going up 5 units, we should be adding it on. So I have f of x is equal to 4x plus 5, and then we need to reflect it over the x-axis. So we need to make this negative, which is going to flip all of our signs. Okay, so we're trying to, our end game should be g of x, so my final equation is g of x is equal to, we divide everything by negative 1, so negative 4x minus 5. Okay, this next one, we have a reflection in the y-axis and a vertical compression by a factor of 1/8. So I got f of x is equal to 4x. Reflection over the y-axis, you have a negative x. So, oops, we're going to make that negative here, which then makes it a negative 4x. And then we need this vertical compression by 1/8. So we're multiplying that 1/8 in there. So now we have f of x is equal to 1/8 times my original here that we had, -4 over -4x. So then my end game is that g of x is equal to 1/8 times -4 is -1/2. And then we still have the x.